present the talk on the biochemical changes during cheese ripening. I'm going to cover the introduction part, changes in the carbohydrate, followed by changes in the protein, and the changes in the lipids, and finally I'll conclude. So, before going to the ripening part, let us understand what is cheese. Cheese means the ripened or unripened, hard or soft or semi-hard or extra hard product obtained by coagulating a milk from the non-animal rennet. Also, the whey protein to casein ratio in the cheese should not exceed that of the milk. That is one thing about cheeses. And it may be, the cheeses may be coated with the food grade waxes or polyfilms. These cheeses may be added with the harmless starter culture, lactic acid bacteria, or the other molds which are harmless. So let us come to the cheese ripening. The ripened cheeses are the cheeses which cannot be consumed soon after the manufacturing. So they must be kept at a certain temperature or the other conditions such as humidity to develop the characteristics, flavor, and the texture. So let's come to the cheese ripening. Cheese ripening is a complex process that involves diverse microbiological and biochemical changes in the curd or the cheese and the end product that leads to development of characteristics, flavor, and the texture. The example of the cheeses are the ripened variety of cheeses are cheddar, camembert, or emmental. There are a range of the ripened cheese like blue cheese also, which is ripened by Penicillium roqueforti, which is also known as blue cheese. So the primary reaction that is responsible for the development of characteristics, flavor in the cheeses there are primarily three reactions. These involves the glycolysis, second is proteolysis, and the third lipolysis. These three biochemical reactions are particularly important. So, although pasteurization temperature kills the most of the microorganisms, but there are certain microorganisms which can withstand the pasteurization temperature. But we'll talk about these later on. But so the most of the microorganisms that may lead to the proteolysis, lipolysis, or glycolysis are now destroyed. Therefore, we need an additional from outer source of microorganism to ripen the cheeses. That is why starter culture are added. Starter culture are the harmless bacteria that are added to the cheeses that provide the desired microflora to induce the chemical changes. And these, enzymes or the microorganisms which are causing the multiple changes in the cheeses during the ripening can be of different origin. These include microorganisms which are added as starter culture. These include the lactic acid forming, particularly streptococci and lactococci, and propionic acid forming bacteria. Certain modes can also be added. The microorganisms that are present in the milk, the rennet, and the milk itself. There are certain microorganisms which are inherent to the milk. Continuing the first is our glycolysis, the breakdown of milk carbohydrate, that is lactose. First we'll talk about the changes in the carbohydrate. The changes in the lactose primarily during cheese manufacturing as well as the certain the first stage of the ripening. Despite of the stage of ripening, it has been published in many studies that the lactose that is originally present in the milk disappear within the 24 hours. There is no lactose in the milk once the cheeses are kept within the 24 hours. After 24 hours, there will not be any traces of lactose. However, certain traces of glucose and galactose are detectable from 7 to 14 days. Then the formation of lactic acid is particularly important for the manufacture, flavor development, normal ripening, and good keeping quality. The formation apart from the lactic acid, acetic acid and propionic acids are also found in the very trace amount. The development is the principal cause of the ripening. The developed lactic acid suppresses the growth of undesirable microorganisms such as coli, erogenous group, butyric acid bacteria, which may lead to the formation hydrogen, carbon dioxide, and butyric acid. There are certain undesirable bacteria which may lead to the certain defects in the ripened cheese. The decrease in the decrease in the pH with the development of lactic acid suppress the growth of undesirable microorganisms. So, moving on to the changes in the protein. The fresh cheeses undergo sense of chemical and physical changes during the ripening, which cause the body of cheese to once there are proteolysis. The first thing that would occur is the cheese will lose its firmness. Tough cutting properties would become soft and mellow. During proteolysis, the paracasein, casein, and the minor proteins are gradually converted to simple nitrogenous compounds. These includes proteoses, peptones, amino acids, ammonia. Insoluble constituents are converted into the soluble constituents, soluble form. The proteolysis occurs in two stages. First, there is hydrolysis of protein to proteoses and peptones. Secondly, the hydrolysis of low molecular weight and amino acids. If a cheese is kept for 1 year, for example, the water-soluble nitrogen compounds will increase to 44.7% out of the total nitrogen. Amino nitrogen increased to 28.4% of the nitrogen, and ammonia nitrogen to 5.4% of the total nitrogen. The proportion of the proteoses and the peptones increase at the first stage, then decrease. The decrease is because of the conversion of amino acid and ammonia. These proteoses and the peptones gets converted to the amino acids and ammonia. Conditions that may increase the rate and the extent of proteolysis are the temperature of the ripening of cheese. If the temperature of the ripening process is increased, there would be increase in the extent of proteolysis. If the addition of the rennet is high, then the ripening would be at a faster rate. If the moisture content in the cheeses are high, there would be more generation of the nitrogen soluble compounds, and there would be accelerated ripening proteolysis process. Less salt. Salt is known to inhibit the proteolysis. That is why if there is less salt, there would be more rapid proteolysis. The larger size of cube, if the size of the cheese blocks are big, then there would be more rapid proteolysis. Then moderate content of low pH, there would be a lesser proteolysis. It is like there should be the moderate pH of the cheeses in order to have a good characteristics flavor and the aroma. Higher pH is not desirable. Neither the higher pH nor the low pH is desirable. So during the proteolysis, the amino acids are liberated gradually by decomposition of para-casein and its intermediate products. There are certain free amino acids that are appearing within the few hours. As soon as the cheese is prepared, there are free amino acids that gives the flavor to the cheeses. Numerous others, there are certain other amino acids that are liberated within the weights that gives typical flavor to the cheeses. Now there are studies that exhibited that there is a direct relationship between the percentage of certain free water extractable amino acid and the intensity of the flavor. If the concentration of the water extractable amino acids are high, the intensity of the flavor in the cheeses would also be higher. It is interesting that the free tryptophan content is it is a direct related with the cheese flavor. The higher the tryptophan content, more would be the cheese flavor. The lipid fraction is one of the major component, but this is the only component that gives the cheeses a diverse range of flavor. Lipid fraction contributes more to the flavor development than any other component. Why? Suppose if we are removing the fat content through the centrifugal force, we are obtaining. Suppose we are making cheeses from the skim milk. The development of the extent and the flavor characteristics of the cheeses made from the skim milk will not be as that much that is prepared from the whole milk or the standardized milk, as the fat is removed from the skim milk. Action of lipolytic enzymes liberating fatty acids by hydrolysis of fat is important in ripening of many varieties with respect to the flavor. So, lipase occurs principally from three sources. The sources can be the milk contains normal lipases, normal milk contain lipases. The source of lipases can also be from the microorganisms that are involved in the cheese ripening, and some rennet preparation also exhibit lipolytic activity. Continuing with this, the lipase are strongly activated by the homogenization process, because once the homogenization is done, there is a decrease in the particle size of the fat. The decrease in the fat globule size increases the surface area, that subsequently increases the accessibility of the lipase enzyme to the fat globules. Thus, also the agitation, foaming, and even change in the temperature also accelerate the process of lipolysis. The agitation is something undesirable. If the cheeses are made from the agitated milk, there are unclean flavor, bitterness, or the rancidity is prevalent in the cheeses which are made from the agitated milk. Milk with a strong lipase activity produces rancid cheese. If the milk has a high lipase content, it may lead to the rancid flavor, which is considered as one of the defects. Moving on to the flavor defects is proposed proportional to the increase in the acid degree of the fat, and therefore ascribed to be liberation of fatty acids. More the lipase activity, more would be the liberation of free fatty acid, and this would further cause the rancid flavor to the cheeses. The microorganisms in the raw milk are principally representative of alkali gins, Achromobacter, Pseudomonas, Serratia groups. These groups are inactivated by the pasteurization temperature. However, these classes of microorganisms are extracted from the raw milk, and the culture of these strains are added to the pasteurized milk. That increases the fat splitting considerably in cheese made from this milk. Milk lipases are normally, that I have told you, these are inactivated by the pasteurization. As I told you earlier, the milk pasteurization, kills most of the microorganisms, but there are certain microorganisms which can withstand the pasteurization temperature. Thus, this plays an important role in altering the course of flavor development during the ripening process. The Penicillium roqueforti produces Penicillium roqueforti, which is used in the ripening of blue cheese. This Penicillium roqueforti produces water-soluble lipase in the system, which hydrolyze fat to yield fatty acids, among which the caproic and caproic acids and their salts are involved, which is the strong flavor and largely responsible for sharp, peppery flavor. Penicillium roqueforti is also known to form, heptanones, which is flavor compounds from the caproic acid, and this ketone is an important flavor component of blue cheese. Thank you. So finally, I will conclude that there are glycolysis, proteolysis, and lipolysis that are responsible for the development of characteristics, flavor, and aroma to the cheeses. The carbohydrate undergoes the glycolysis, that is lactose gets converted to the lactic acid, and some other acid that includes lactic acid, formic acid, and propionic acid. The lactose completely disappear within the 24 hours. There are traces of the glucose and galactose that persist for 7 to 14 days. The proteolysis that takes place, there are conversion of there are liberation of proteones and peptones, and the liberation of free amino acids. The content of tyrosine is particularly important. More the tyrosine, more would be the characteristics flavor. Lastly, the fat content, which is the fat is the only component which is majorly contribute to the flavor characteristics of the cheeses. Thank you.